I want to first say that what I'm going to talk to you about today is theory, not yet fact. It's my best interpretation of what's going on in the body, with water collaborating with light to do magical things. It's not yet proven, but I'm hoping research in the future will, in fact, verify that I'm right. So I want to start with a little bit of a metaphor. You look at a street, the streets provide the highways, they connect the houses together, people can travel, you deliver goods. But there's also power lines along the edges of many streets. We don't see them, we aren't aware of them. But they're, of course, providing electricity to all the homes and the businesses. When you get into the house, you see the walls, they're providing structure for the house. But the power lines are coming in and going inside those walls, and they're going over to a plug where you plug in a computer and charge it up. You take that for granted. But the walls, they're providing structure, but they're the path, the conduit by which the electricity reaches the plug and therefore your devices. There's something similar going on in the body. The body, of course, has this massive blood network that supplies goods, takes away waste products, does very important things for the body, but it's also a supply of the electrical circuit for the body. And each individual cell has a cytoskeleton. This gives it structure, gives it strength so it doesn't get smashed. But that cytoskeleton is also a source of electricity, the electricity coming in off of the network, traveling through the cytoskeletal fibers to provide electricity to the internal of the cell. So here's a schematic of a simple cell. And this cell, you can see these plus signs throughout going along these cytoskeleton pathways, and those are protons. And they're coming in from the outside, but who's making those protons be available? That's the structured water. It surrounds the cell, and the cell works very hard to maintain that structured water. And when there's sunlight, it will grow, and that will make more energy. But the plus signs are gathering along the edge, along the interface of the structured water with the unstructured water outside of it, and they can be channeled up into these caveoli, these little caves, and then brought right into the cytoskeleton to provide those positive charges to certain organelles in the cell that need positive charge. And in particular, one of those is the lysosome. Lysosomes need to be extremely acidic in order to do their job, and their job is to clear molecular debris. Very, very important, get rid of the garbage. As they draw in these plus signs, these protons, they get lower and lower pH, and now they can do their job. If that electrical circuit is not supplying enough protons, they can't do their job. The debris gathers up, and you get things like Alzheimer's disease from amyloid beta plaque. There's also the mitochondria. Those are the source of energy for the cell. They make the ATP, and they also depend on protons to supply a lower pH in their intracellular membrane compared to the pH in the interior world. They need that pH drop to drive the generation of the ATP that supplies energy for the cell. What I'm saying, and the most important thing in this talk, is that structured water that is maintained outside the cell. It's a special gel form of water. It's not liquid, it's not solid. And it also induces this charge separation that creates a battery. And what happens then is that the cell uses those protons to go into the cytoskeleton to supply the positive charge, and the electrons stay inside the structured water, and they provide energy for another very, very important purpose, probably other purposes as well, but one that I'm very focused on is the synthesis of sulfate. And the reason why this is important is because the sulfate actually maintains the gel. Each cell decorates its exterior with lots of sulfates that are attached to these extracellular matrix sugars outside the cell. And those sulfates are really important for maintaining this structured water. So it's circular. They're made by the energy that the structured water creates when it responds to light, and then they maintain the structured water. So when that system falls apart, lots of bad things happen. So here's a picture, very schematic, of red blood cells traveling through a capillary. They're very crowded in the capillary. It's a very tight squeeze. They decorate themselves with sulfate outside their cell, and they deliver that sulfate as they pass through the capillary. They shed it, and they're therefore shedding negative charge. And that negative charge is then building up along the capillary wall. And it's very interesting because as they do this, by the time they get to the vein, and all of them are shedding their negative charge, this creates a battery between the artery and the vein, which then actually propels the red blood cell through the artery, through the capillary, because it's attracted to the venous side because of this battery. It's attracted to the cathode, and that will pull the red blood cell through so that the heart doesn't have to work so hard to pump. And furthermore, these layers, these sulfated layers along the wall of the capillary are very slick jello. The red blood cell can just slide through almost frictionless effort to get through that capillary. When these things break down, the red blood cell gets stuck and you have a no-flow situation. So basically, this voltage change that's created by the red blood cell itself actually drives the red blood cell through the capillary and makes the blood flow properly. So here's a schematic from a paper that I've written with colleagues. And what's really interesting is that when you think about a red blood cell negatively charged moving through a region, that's going to create an electromagnetic field. And the body can use that as a signal, and in fact the body does. Very, very important signal. The wall of the capillary end of the arteries releases nitric oxide. These little guys over here are nitric oxide. Nitric oxide is very important in the blood because it relaxes the muscles and allows the blood to flow. So it's really interesting that as the red blood cell moves, it triggers the release of the nitric oxide, which encourages further movement. Really interesting process. So here's now a capillary cross-section of a red blood cell. We're getting a little bit more into detail here. We have a bunch of things that we're pointing to. You can see the negative charge surrounding the red blood cell. That's actually cholesterol sulfate. Cholesterol is an important part of what makes the sulfate work. And the red blood cell has these cholesterol molecules in its membrane with sulfate sticking out that gives it that negative charge. And it sheds those cholesterol sulfate molecules as it goes through. They hop over to the other side and go into the endothelial cells, providing them with both cholesterol and sulfate. You can see I have these little sulfate molecules showing around the interior. We've got a few endothelial cells wrapping it around. And then they have this complicated glycosaminoglycans in their extracellular matrix. That's all these little strings there. That's the sugar chains. Those things have sulfates attached to them, and that's what's maintaining that structured water, that easy water that's going to make everything work very, very well. And then, of course, you have the protons gathering along the inside there, and you have this battery created within the structured water that can provide energy to the cells. So this is my provocative proposal. Cholesterol sulfate supplies oxygen, sulfur, cholesterol, energy, and negative charge to all the tissues. Very, very important list of things. Sulfate has 4 oxygen molecules, so this is another way that the red blood cell can actually deliver oxygen to the tissues. It has the oxygen bound to the hemoglobin, but it can actually deliver the oxygen in the form of sulfate. And of course, the negative charge and the energy are very, very important. Sulfate is synthesized in the skin and in the red blood cells and in the platelets using the energy of sunlight. So if you look at the veins in the back of your hand, hold those up to the sunlight, you'll be making lots of sulfate. And that'll be combined with cholesterol to make cholesterol sulfate. And then that will end up making your cells very, very happy. And we believe the molecule that does this is the same molecule that makes the nitric oxide, which is very, very interesting. That we have written in 2 papers now, this group, claiming that endothelial nitric oxide synthase, eNOS, a very, very interesting molecule, can oxidize both sulfur and nitrogen. And it chooses which one to oxidize based on the situation in the current environment. It's constantly monitoring the signals, for example, the electromagnetic signals, to decide which one to make on a case-by-case, moment-by-moment decision. So the skin then is a solar-powered battery, and we are able to use the sunlight for energy just as the plants are. But we do it in this very different way that's actually going to provide us with what animals have, which is mobility and a brain. We have a nervous system. Plants don't have that. They use the sunlight very differently. So this is my bold claim. Deficiencies in cholesterol and sulfate supplies to the blood and to the tissues are the most important factor behind modern diseases. And I have looked at many, many modern diseases, and I can see that in many cases what's happening is the body is attacking a particular organ or an organ system in order to get at the sulfate that's there, in order to give that sulfate to the blood because the blood is deficient. If the blood doesn't flow, the body doesn't work. So that becomes the #1 priority, and various organs get sacrificed. And that will explain different kinds of diseases like rheumatoid arthritis and Alzheimer's and autism. So eNOS, unfortunately, is very vulnerable, and this is why we face a problem right now. It has a lot of dependencies. It depends on vitamin B12, which is cobalamin. That means it depends on cobalt. It depends on iron because it has a heme group. It depends, of course, on sulfur. There's a zinc atom in there. Of course, oxygen, glutathione, the antioxidant glutathione, and of course, sunlight. And so because eNOS is vulnerable to many different environmental toxins as well, such as mercury, aluminum, and particularly glyphosate, which is the one I've studied the most, which is in the pervasive herbicide Roundup that's pervasive in our environment, in our food, in our water. Roundup, I think, is causing a serious problem for eNOS, which is causing us to have this massive sulfate deficiency. So eNOS, in fact, it's a member of this class of enzymes called cytochrome P450 enzymes, which both aluminum and glyphosate have been shown to suppress. So how to stay healthy? Eat a strictly certified organic diet. My husband and I have been doing this only for the last 3 or 4 years when we first found out about glyphosate. It has done wonders for our health. We totally believe in it. get lots of dietary sulfur. That means great foods like broccoli, garlic, onions, seafood, liver, for example, if you can get a healthy liver. Get out in the sunlight as much as you can. I love to take walks on the beach, in the water. You're getting everything there. You're getting the grounding, you're getting the sunlight, and fresh air. So really, really useful to take a walk on the beach in the sunlight. In summary, the human body uses sunlight to make sulfate, which maintains gelled water surrounding cells. That gelled water induces charge separation, and that supplies electricity to the tissues. Sulfate is essential to prevent a no-flow situation in the blood. That's why the red blood cells can scoot through so easily through the capillaries. Makes the heart sing because it doesn't have to work nearly so hard. Enos is a magical protein that makes sulfate in response to sunlight, but it's highly vulnerable to both deficiencies in certain nutrients and poisoning from various toxic chemicals, especially Roundup. So the path to good health includes a sulfur-rich organic diet, lots of sunlight exposure, and frequent grounding. And then two things that I would like to see happen, two studies that need to happen in my opinion. Of course there are many, but these are my two top picks. One is to confirm that I'm right about Enos making sulfate, because so far it's just a theory. We have a detailed written up account of why we think this is happening, but it hasn't been proven. Enos oxidizes both sulfur and nitrogen and depends which one on the environment to be able to control the blood flow and get the blood just right to be able to move. The second one, which I haven't mentioned but which I feel is very important, I believe that glyphosate is getting into proteins by mistake in place of glycine. Glyphosate is a glycine molecule with an extra thing attached to the nitrogen. I've written papers about this, and I feel the evidence is really compelling, but it has not been shown. And I believe that chemists ought to be able to design an experiment which would show that this is in fact happening. Thank you very much.